Hello and welcome to the first video series of electronic basics, and in this video we will be learning about the numbering system that we use in electronics environment. First is the binary format that computers can understand, that is 1 and 0. Second is the hexadecimal format that programmers use to represent large chunk of binary numbers into smaller hexadecimal format. So without wasting any more time, let's get started. First of all, before we dive into binary numbers, it's important to note that the number system that we're used to is called decimal numbers. The reason why it's decimal is because it represents 10, and the numbers in decimal system are represented from 0, 1, 2, all the way till 9. So computers are not able to understand this format, they only understand 1 and 0. So that is why it's important to break down the decimal number that we're all used to down to binary numbers so that computers are able to understand and process the information. So the binary number or two number system is represented by 0 and 1. So let's consider 1 byte. 1 byte equals 8 bits. So the ordering of the bits starts from the far right, which is the 0 bit, 1 bit, 2 bit, all the way towards 7th bit. So it's important to note that these ordering of bits represent the powers of 2. So 2 power 0, 2 power 1, 2 power 2 till 2 power 7. So let's consider 1 byte, which is 011001110, and you want to represent this byte into a decimal format. So what you do is you take each of those bits, multiply them by the corresponding powers, and the result comes up to 102. Let's consider another example. 01001001. You multiply each of those bits by the corresponding power. So you multiply them by 64, by 8, by 1, and add those up. You get 73. Now if you want to go the other way around, that is from decimal to binary system, there are different approaches available online. In my opinion, the most simplest and easiest approach is using the division approach. So let's take a decimal number 65. So you divide 65 by 2. So 2 goes into 65 32 times with the remainder of 1, and then you continue the chain. 2 goes into 32 16 times with the remainder of 0, and 2 into 8 with the remainder of 0, 2 into 4 with the remainder of 0, all the way till the end. So then you count the bits from the bottom up, that is 10000001. This concludes our binary system, and now we'll move on to hexadecimal. So the hexadecimal or 16 number system is a representation of 16 different hex values ranging from 0, 1 all the way till 9, then A, B, C, D, E, F. Now let's use the same approach. Let's suppose we have three different hex values, that is 3, 4, A. Now the ordering of the hex values start from the far right, which is 0 hex, 1 hex, and second hex, and you multiply each of those hex value by their corresponding power. So A times 16 power 0, 4 times 16 power 1, 3 times 16 power 2, and then you add them up and you get 842, which is a decimal representation of a hexadecimal value, that is 34A. Now suppose we want to reverse the process, that is represent 842 decimal into hexadecimal. So you divide 842 by 16. So 16 goes into 842 52 times with the remainder of 10. Now 10 in decimal corresponds to A in hexadecimal. Then 16 goes into 52 3 times with the remainder of 4. Once you're at the end, you read the hexadecimal values from the bottom up, that is 34A, which is the same decimal representation of 842. Now we'll consider hexadecimal number with respect to binary numbers. Now this is where it gets really interesting. The beauty of hexadecimal system comes when you're able to represent 4 bits of binary number into one hexadecimal number. Now the reason why it's 4 bits is because you can have 16 different binary representation with 4 bits. Hence 4 bits corresponds to one hexadecimal value. So that means that you can represent 1 byte, which corresponds to 8 bits, into 2 hex values. 2 bytes, which corresponds to 16 bits, can be represented with 4 hexadecimal values. Now let's take 2 bytes for example. 2 bytes corresponds to 16 bits, and what you need to do is you need to separate 16 bits into 4 different bits. So 16 by 4 represents 4 different sections. So it first corresponds to 0001, then 1101, then 1100, 1001, and then you convert each of those 4 bits into decimal, then to hexadecimal. So 0001 corresponds to 1 in decimal, which is the same in hex value. 1101 represents 13 in decimal, which corresponds to D in hex value. 1100 corresponds to C, and 1001 corresponds to 9 in hex value. So as you can see that a 16-bit binary system can be represented into 4 hexadecimal value. That is why hexadecimal system is so commonly used by manufacturers when they develop their own data sheet for their devices. So once you read the data sheet, you're going to see that memories, unique addresses, and other information, they're all represented in hexadecimal values. So the understanding of hexadecimal system is going to be very vital for our understanding of electronics when we do later electronic projects and understanding of later electronic concepts. This concludes the end of our video, and if you haven't subscribed to the channel, please do not forget to like, share, and subscribe. Remember, robotics is the key to the future, and until then, I'll see you next time.